Hi, my name's Alex, and my partner is Sumaya, and me and her did the What is Engineering project on electrical engineering. Electrical engineering is a more recent branch of engineering that became a profession within the 19th century. It carried significant industrial and technological relevance uh, from radios and electronics throughout World War II, the space race, the Cold War, etc., up until the modern day. It's important to note that electronics are not limited to technologies such as computers and phones. An electric fan is technically also an electronic. It's the uh, electrical engineering is what made the shift to an electric-powered society possible. For example, electricity to power lights and warm rooms instead of having fires and candles and more fires from fireplaces and firewood, because those are less safe and just less efficient in general. It Electrical engineering concerns things related to electricity and electromagnetism. Electrical engineers work on a wide range of components, devices, and systems, wires and circuits and machinery powered by electricity, and other such things are within the field of electrical engineering. So, in more ancient times, we knew that amber could be rubbed with to create static attraction, but not much was known within the electrical engineering field otherwise. In the 17th century, we had some people that looked into electricity and magnetism, but it's like not that many people. And during this time, we started to get the words electric and electricity. In the 18th century, insulators and conductors were found to be relevant and useful to us. We also found that lightning was electric, courtesy of Benjamin Franklin, and electricity was found in nerve cells in our body to signal different parts of the body. In the 18th century, well, my bad, in the 19th century, electrical engineering became a job. It was a profession we could work in. Electric telegraph networks could connect long distance. We got radios, we got refrigerators that were electric instead of your ice box, and we also had more electronic technologies in general. It was just a lot of stuff, basically. In the 20th century, we started to move to getting long distance calling and TV, and radar was also invented during this time, and it was used in war, namely in World War II and the Cold War. Uh, the main thing that came out during this time were more advances in radios and electronics in general, and also during the later parts of the century, we had uh, the internet, which we were able to access via electronics. And in the modern day, I mean, we have the internet. We became more reliant on the internet. So we became more reliant on electricity in general. Uh, so uh, Electrical engineering is also very useful to us in that it provides lighting and heating. We get light bulbs to power our lights in our homes, in our schools, etc. And we get heat for food, for rooms, for water, for air conditioning, etc. Everything, really. Food can be stored and kept fresh, cold, or hot. We can travel all around the world, air travel with radar and electricity to power certain parts of airplanes, and we have GPS via satellites, which helps with cars. We have entertainment in the form of TV now able to be transmitted to all of us live. We have convenience in the form of something like, say, a calculator to help us do math more efficiently and quickly. And we have programs for 3D modeling, etc. Just a lot of different new stuff comes out that is just a lot more convenient for all of us now. Most things to do with electrical engineering come hand in hand with mechanical engineering. So, say the radio. The radio was produced by mechanical engineering and also electrical engineering. We had the radio to allow for long distance communication. It was multi-purpose in general, really. Radar was also used to detect location, speed, and of course objects. It was also pretty handy for making predictions about the weather. The internet kind of just goes without saying. I mean, we need electricity to connect our PCs or desktops or whatever to the internet, um, and computers because they're pretty much the superior, more efficient versions of our human brains, except mainly in binary. And yeah, they have connection to the internet too. Also, in collaboration with military engineering, we have the railgun. Not the railgun that you see on screen right now, but um, this one. And it's a weapon used to accelerate a projectile using a magnetic field that's running on electricity.
Alright, so for electrical engineering jobs, electrical engineers often work in groups for research and development industries, engineering services firms, and manufacturing industries including consumer electronics, computers, traffic control, etc. And they work for the federal government, which you can often see in the military. A typical electrical engineer project will consist of inspecting completed installations to make sure that they're complete and they follow the safety and operational standards set. In addition, they also conduct field surveys or study maps, graphs, diagrams, or other data to identify incorrect systems, or they design software equipment for performing engineering tasks. As for their salaries, electrical engineers work more than 40 hours per week, usually from 9 to 5. They generally work indoors, but sometimes they go outside to see the task at hand. As for their average salary, in New York, it ranges from 66,000 to 88,000 per year. It's $75,805 per year. Salary ranges can vary widely based off your education, your certifications, and the number of years you spent in your profession. Most electrical engineering jobs require at least a bachelor's degree in engineering. Most employers, at least those who provide engineering consulting services, require state certification from the IEEE or the IET. Universities or colleges that offer degrees in electrical engineering include Cornell University, Columbia University, and Cooper Union for the advancement of science and art.